Hello my dear students. After seeing functions which has been covered in last 5-6 hours, we shall now move on to very interesting topic in C program or in any other programming language for that matter, will be called as arrays. Whenever you would like to store elements at the individual level, we call them as a primitive level. We use integer, float, character, like this actually we try to store. Whenever you would like to store group of elements, set of elements of similar type, then you will be going for arrays. Obviously, in a daily life, in most of the applications, we will not be operating on a single data. You will be operating on set of data. If you take the students of one section, you will have 60 students. So therefore, their names will be it will be string, the register number, their roll numbers. So you have set of students, set of faculty members, set of classrooms, set of colleges, set of account holders, set of farmers, set of ministers. Whichever you take, always it will be in terms of group. It will be in terms of more number of elements, not a single element. So far we have used applications with operating on a single element. As we proceed, we need to look at how to incorporate more number of elements in one group, in one handler. Like for example, integer, we used to take NUM, int NUM. NUM can store one integer. Now, I want to store 60 numbers, 80 numbers, 1000 numbers. 1000 numbers to be stored, 1000 names to be stored. It is not just one single character. Now it is 1000 names to be stored. So therefore, as we go higher and higher in the programming language, you got to see usage of multiple homogeneous type of data. What is homogeneous? See, I cannot mix up one integer with a character. No. Set of integers, set of characters, set of float. Like this you can keep on storing similar type of data in a consecutive locations. In a group, it is called arrays. Arrays are basically to store homogeneous or a similar type of data together. Do we have something which is to store non-homogeneous? Yes, you will be studying this in module 5. It is called as a structure. Structure will be studied in module 5, wherein which you will be using a single handler to accommodate heterogeneous type of data. But right now, we are into the chapter of arrays, where you will be discussing how to store similar type of data in one group or in one handler. One handler means I am giving one name to it. When I am calling an array of roll number, it can have some 60 roll numbers. Array of names, it can have 60 names. Array of salary, it is a float. Array of age of all students, then it is a set of 60 numbers. Age is a number, so therefore I am trying to store 60 numbers together. It is called arrays. Arrays are more fascinating and more versatile and most used data structure in programming languages. We will be seeing some aspects in today's video, how exactly arrays are declared, how to access the arrays. There is a concept of accessing the address and how to find out the length of the array, then how to store inside the computer, then you will be doing some operations onto the elements. operation onto the array. Like we have here traversing, then we have here searching, inserting, deleting, merging, sorting, all those things. So we will see one by one how exactly these arrays are being utilized inside the machine. Arrays are declared just like any variable that you are declaring, but you have got to tell what type of homogeneous type of elements this is storing. Say for example, an array is declared something like this, integer. Integer means now I am declaring an array of type integer. It means it can store integer set of numbers. It is not only single number, it is an array, it is a set of numbers. So to call it a set of numbers, I am giving with the square bracket. Functions are used with the open bracket. Flower brackets are used for loop, do loop, or some set of blocks. And square bracket is used for arrays. You have to understand there are three types of brackets we use. One, this angular bracket, right? Conventional bracket which is used for functions, right? Then we have your flower brackets which are used for blocks or for loop, do loop, switch, etc. and all blocks of statements. And square bracket is used for array. Say for example, now I am calling an array as roll number. Roll number is an integer type, but if you simply write like this, this can store only one number. If I call int roll number, this roll number can store only one number, but you would like to have more than one number, then I have to use a square bracket. This is the difference. If you write without square bracket, then it becomes single number. If you write with the closed and open square brackets, then it will become an array. And you have to tell. And you have to mention how many elements you wanted to store. Would you like to store some 60 roll numbers? Then write 60. Or you would like to store only 10 numbers? Write 10. How many numbers you would like to store? That many number you have to mention, right? Say for example, I am storing 60 students roll number. So therefore, I am just doing this like this. Similarly, I can store this character A of 10. What does it mean? It means it can store characters. How many? 10 characters it can store. This can store 60 integers. Roll number is now not a single number. It is set of integers. How many? It is of 60 size. Similarly, how many characters it can accommodate? It can accommodate 10 characters. So A is an array of type character. It can accommodate 10 different characters. Whatever you would like to store, you can just store like that. So this is how arrays are declared. You can use it for float, real numbers, or you can use it for integer, you can use it for character, like this, right? So this is how the arrays are being declared. In fact, there is a way of declaring in a multi-dimension also. 2-dimensional array, 3-dimensional array also can be stored. But now let us restrict ourselves only to single dimension array. Single dimension array like this. When I declare integer roll number 10, it means roll number, it can now store 10 numbers. It can store now 10 integers. One here, one here, one here, like this actually it can store. Right? So this is how you are supposed to start imagining the arrays. Whenever you declare an array, some memory locations are allocated to it. Some memory locations are allocated. Even in our conventional declaration also, if I have declared integer d, how does the computer works? Now, when you do the compilation process, some bytes will be allocated to variables. How many bytes? For integer, it is always 2 bytes. For character, it is 1 byte. Right? Then for float, it is 4 bytes. If you are going for long int, you know that, then this becomes 4 bytes. Then you are going for double float, then it becomes 8 bytes. Conventionally, if you do not mention anything, then it becomes an integer which is of type integer, then it will be taking 2 bytes. If you are going with a character, it occupies 1 byte. Float means it occupies 4 bytes. In case if you are going with a long int, I have already explained on the earlier videos. If you are going with the long videos, instead of 2 bytes, it go for 4 bytes. Similarly, if you are going for double float, then it goes for 8 bytes. Okay, we will now restrict ourselves only to 214 like this, assuming our data will be well within this particular range. Alright. Now, when you declare a variable like integer d, 2 bytes of data, 2 bytes of memory location is allocated somewhere. Similarly, when I am declaring character A, 1 byte of memory location is allocated at some location. So that is the address. Where some space is allocated, say for example, when you come to college, some space will be allocated to you. Today, it may be in one classroom. Next day, it will be in another classroom. But where you are sitting is known to us. That is actually the timetable. So where are you sitting today? You are sitting in a specific classroom. So where you are sitting, that classroom is known to us. That is a timetable. In a very similar way, when you declare a variable, some space will be allocated to that particular variable by the memory manager by using your operating system. The compiler asks for operating system to give one space, one area, one location, and location is granted. In that you will be operating. If you are integer, means 2 bytes of data will be stored there, like that. Similarly for character, similarly for float, etc. and all. So therefore some memory will be allocated. Whereas in case of array, it is more. Since I am storing 10, since I am storing integer with a size of 10, so therefore 10 into 2 bytes. Each number, each integer can be there with a 2 bytes. So therefore 2 plus 2 plus 2 plus 2, so therefore there are 10 elements, so therefore 10 into 2, so this becomes 20 bytes. You will be storing an array with the size of 10. You can estimate yourself now, character A 10. It means A is an array of type character. So therefore it is 10 into 1. Because each character is taking 1 byte. Just now I told you it is 10 bytes. What does it mean? It means if you are declaring integer roll number of size 10, 20 bytes of continuous memory location, consecutive memory locations are allocated to this array. Similarly, if I am declaring character A of 10, consecutive, successive 10 memory locations are allocated to it. 10 memory locations are allocated to it. It means, say for example, you are in a specific section. In that section, if there are 20 students are there, for each of the student, how much space is required, that much space is allocated. If the class strength is 120, you cannot be accommodated in a smaller area. So therefore 120 into how much of each student can sit, that much space is allocated. Like that, when I am declaring integer array, integer roll number of size 10, it has become an array, therefore 20 bytes of memory location is allocated, right? So, when you declare an array, we use another terminology called as an index. What is this index? This index is nothing but the number which is now given as a reference for your understanding about individual data inside this array. Inside this array there is a individual data. How exactly you will be accessing, you will be meeting each of these elements inside this array. So this is called as zeroth element. Please observe this carefully. It doesn't start with 1. In case of array, it always starts with 0. This is the zeroth index. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 0 to 9, it means it is 10 elements. 10 integers. 10 integers. Each location, I am calling it is, this is one box. In this box, I can store one integer. Similarly, another integer here like this. Each integer takes 2 bytes, so therefore this is taking 20 bytes. Alright. Now, I am starting with the address 0 like this. Index, it is not address, sorry, it is an index. Index of the first element is 0. Index of second element is 1. This is very crucial. Many people get confused. Index starts from 1. No, it starts from 0. You should start from 0 and then go up to the end. In this case also, index, always the index starts from 0 and go up to how many elements are there. Say for example, I have declared an array of type character, its name is A, of size 5. Then I am having one array 1, 2, 3, 4, 5. Then this can store one character, this can store one character, this can store one character. 5 characters can be stored. Index is 0, 1, 2, 3, 4. Its index is 0. Its index is 1. Its index is 2. Its index is 3. Its index is 4. Now, don't get confused with the address. Address, whenever I declare an array, some location will be given to you. That location is the address. Say for example, now there is a rack. There is a rack. In this rack, I am keeping notebooks here. When you go to your shopping, bazaars, right? Shopping mall, you will be seeing some racks. Assume that in the bottom rack, all notebooks are kept. Here, soaps are kept. And here, toothpaste. Now all soaps are stacked here. Similarly, all toothpaste, all notebooks that they can sell, they kept it here. All homogeneous items are kept at some location. All soaps are kept here. All toothpastes are kept here. Now, when I am calling this as an array, the first toothpaste is having address as 0. Its index is 0. 1, 2, 3, 4 like this. Similarly, this is 0, 1, 2, 3 like this. Similarly, this is 0, 1, 2, 3 like this. It goes on. It goes on from bottom. Let us consider. Now, if I would like to go here, this address is something different. This is called as the base address. This is called as a base address. This is called as a base address. Some location at which you have been given the space to keep toothpaste. This is given in the third stack. In the third stack, the toothpastes are kept. So the third location is the base address of this array. In that you have 0th element, first element, second element, third element, fourth element, which is an array. Similarly, the base address for this is different. The base address is actually 1. This is ground floor, first floor, second floor, like this actually. In the second floor of that stack, you have here 0 index, 1 index, 2 index, like this. So 0 index is the toothpaste, 1 index is also toothpaste. All these are homogeneous. All these are homogeneous. They are all soaps. These are all notebooks. But this base address is different, its base address is different, this base address is different. So, depending on the base address, the other addresses can be computed. Say for example, I have here 1200 is the location at which you have been given the space. It means this is at 1200, this is at 1202. Why it is 1202? Because this is taking 2 bytes. This is 1204. This is at 1206. This is 1208. You know that for every integer I require 2 bytes. So therefore, if I am storing, if the starting address of the array is 1200, at that location 0th indexed value is stored. If I am calling this is the second floor, at the second floor the first index element is the toothpaste. The second toothpaste box is kept at this second floor first element. Similarly, where is the third toothpaste box? Third toothpaste box is kept at second floor index 2, like this. So you have to keep on going like this. 1210, it goes on like this, 20 bytes. Similarly, if by chance assume that you have been given it a space somewhere near 3600. I am taking some arbitrary number, right? Just like first floor, second floor, like this. This is the location at which you have been given space by the operating system. Then this will be at 3600. Tell me, where is this? This is at 3601 because this is taking 1 byte. This is taking 1 byte, so therefore 3602. This is 3603. This is at 3604. At 3600 location, you have your first data. At 3600, when you have second data, 3602, third data, like this. Its index is 2. Starting index is 0. So this should be very carefully to be observed. And the size of this varies from what type of declaration that you have made. If you have made integer, then it is 2 bytes. If you have made character, then it is 1 byte. If you have made float, then it is 4 bytes. Take that case also. So float salary of 5. When you declare the salary, one float number, second float number, third, fourth, 5 numbers can be stored, right? So therefore, what is the index value? This is the index is 1, 2, 3, 4, like this. Then when you declare this, some location is given to you, some number, you call it is 1250. What is this 1250? This is the location at which you have been given a space. First floor, second floor, like this, I told you, in that way. 1250. It means at 1250, you have the first element, first float number. Where is the second element? Second element is there at 1254 because this is taking 4 bytes. Right? Next, this takes 1258 because this is taking 4 bytes. This is taking 1262, 1264. And which is the ending? This is 1267. 24, 25, 20, 64, 65, 66, 67. Fourth location. 50, 51, 52, 53. 50, 51, 52, 53. Then start with 54, 54, 55, 56, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64. Like this it goes on. Right? So because each of them is taking now 4 bytes. This is taking only 1 byte. This is taking 2 bytes. So this is what you are supposed to understand. Accessing any element of an array is through the index. Say for example here, I would like to go to the 5th toothpaste. I would like to pick up the 5th toothpaste. Can I go? Yes, I can go. I have to go to this location. From there I have to count. I have to go to the 2nd floor. First I have to go to the 2nd floor. From there, go to the 5th index value. So here also, you can see here, if I would like to go for a 5th element, 0, 1, 2, 3, 4. So therefore, this is the element. Right? While declaring, you will be declaring like this, int roll number. While accessing, you can write like this. I will write a small program. See here. Include stdio.h main integer roll number 10. I have declared one array of type integer of size 10. Right. Then roll number of 1 equals 55. What does it mean? A value called 55 is stored at the index called 1. Where is it? Here it is. It is not here. It starts from 0. So therefore, 55 is stored here. I would like to store 55 into an index value called 1. I can write like this. Now, roll number of 7 is equal to 18. What does it mean? Go to the 7th indexed value, 0, 1, 2, 3, 4, 5, 6, 7, this one. At this point, you store 18. Observe this carefully. Index value starts from 0. When I say 7, it is not 1, 2, 3, 4, 5, 6, 7. No, not this one. Index value 7 means basically it is a 8th element in our conventional decimal system. 8th value, because the index starts from 0. 0, 1, 2, 3, 4, 5, 6, 7. Next, roll number of 0 is equal to 26. I would like to store a value called 26, which is an integer, into roll number of 0. Roll number of 0 means this one. I can store 26 over here, like this. I can keep going, accessing randomly, not necessarily you have to go in sequence from here only, not necessarily. This is the biggest advantage of arrays. Computer science students, you will be studying subject called data structures in your 3rd semester. When you reach there, you will appreciate the beauty of arrays. This is the only data structure. Of course, there you will be studying array also as a data structure. Arrays, stacks, queues, linked list, trees, graphs. You will be seeing many things like that in your 3rd semester syllabus, subject called data structure. Array will be dealt again. But I am always comparing array at one level, one side, rest of the data structure in other level. The reason is this: arrays permits you to access any value directly, whereas rest of the data structure you will be studying in your 3rd semester they don't have that facility. Random access is permitted only in arrays. What does it mean? Now, say I have filled up, see here 1, 2, 3 values I have filled. This is 26, this is 55, 18. I can use these values randomly. I can print this value directly now. I can print this value directly. I can print this value directly. Not necessarily I have to go in sequence. I have to move from left to right only or right to left. No such kind of requirement. You can directly access any indexed value of the array directly. So that is the biggest beauty, biggest advantage of arrays. Right? Of course, there are some disadvantages of array. You will see them later. But as a student, the biggest advantage you got to understand of this array is actually it permits you to access any element randomly. Assume that I filled up all these numbers. I can go to the 4th element directly. Then I can go to the 0th element, just like your textbook. So I can go to any page. From there I can come back to 0th page, then go to the last page. You can go. That permits you to go for any page in a textbook. Like that, arrays, once it is stored, you can access them using the index directly. You need not have to worry of going in a specific sequence. So this is the biggest advantage of the array. Right? Next, the next possibility is actually calculating the address. Calculating the address, now it's very easy for you. Right? Say for example, calculating the address may not be so much requirement in your programming languages. It is required only in some exception cases. Anyway, that is there in your syllabus. Let us try to do that. Right? Say for example, I would like to find the address of this. What is address? You know that it is 11206. How did you compute that? There is a formula called A of k. Address of the kth element is equal to base address plus word length into k minus lower bound. So where kth element, BA means base address, W is the word length, then LB is the lower bound. Not a very big equation to remember, nothing to worry. Say I would like to identify the address of k. Say for example, I would like to go for the address of 3rd element, this element, right? 0, 1, 2, 3. What is this? Address of 3rd indexed element can be found out by 1200. That is a base address plus word length. What is a word length? Word length, it is an integer type. Integer type, so therefore it is 2 bytes into k. K is 3. 3 minus lower bound. Lower bound I start with 0. So therefore I start with 0. So therefore it is 1206. At 1206 you have 3rd indexed value. So like this you can find out the address of any location, any indexed value by using this formula. A of k is equal to BA of A plus W of k minus LB. I mean, they are all very, very simple to understand. You can easily find out, right? What is a length? What is a length? Length can be easily be found out. This is nothing but upper bound minus lower bound plus 1. Length, upper bound minus lower bound plus 1. So here you have your 9 minus 0 plus 1. So this is the formula. The length, see, when you are declaring the length, you know that actually what is the size of the array that you have declared. So therefore, this may not be so much relevant. I have already told you about the storing. Storing any element in the array is on a random basis. So you can access any memory location directly by using like this. You can as well read that also. How to do that? You can do like this. I'll just wipe off this. Observe this carefully. I have declared an array. Which is of type integer of size 10. Its name is roll number. It means it can store 10 elements. Its index value starts from 0. It goes up to 9. As I told you, you can read using your scanf statement also. So scanf %d roll number, where you would like to read. I am interested to read and store it as 5th element. Somebody types a number called 23. The 23 will, whatever the value that you have typed by using the keyboard, so that will go to you are reading it as an integer, %d means it is an integer. Where it should go? It should go as a 5th element. So therefore, here it comes 23. You can do, but only one difference that you would have observed by this time. In most of the cases in scanf, we used to give an address here, ampersand we used to write, but here if it is an array, we don't write that. Because when I say array, that itself is an address. Don't get confused. Whenever you have an array, I am not writing the ampersand. Just keep in that way. Later we will see why it is not there like this. So whenever you have an array element, I am not writing the address. So the reason itself is this itself is an address. Roll number 5, that itself is an address. So therefore I am not writing the ampersand. Right? Similarly, I can now do like this, scanf %d roll number 0. It means you are expecting somebody to type in through the keyboard and that value to be stored at 0 index value. 0 index value in the roll number. Assume that he has typed 56. The 56 will come here. So this is how you will be storing the values inside this. You can use a for loop also. To read all these 10 numbers, I can use a for loop. Right? Let me just change the program. I'll write here. Integer I for I equals 0, I less than 9, I plus plus. I am simply doing it like this. Scanf %d simple. You will be reading all 10 numbers starting from 0 index value till the 9th index value. It means totally 10 elements. Because I am again starting from I equal to 0 to 9, it means it is 10. So scanf percentage the roll number of I. So first time I equals 0, so you will be reading the first value. Whatever you has typed, it goes here. Second time I plus plus, I am doing it. So therefore, again I am doing I equals to 1. So therefore, here it is stored. It is stored here. It is stored here. So it's stored till the last value. So you can close this program. So this is a program to read all 10 elements by using one single for loop. In a single for loop, I would be able to read this. Alright? Okay. So today we have seen this array, declaring the array, accessing the array, finding the address of the array, finding the length, and storing the element by using the keyboard, or you can directly accessing it by the individual values or through the variables. In any way, in any mode, you can just do that. I have shown with all the possibilities. So in the next video, we will go with operations on arrays. See, ultimately when arrays are there, it is not just only to store. Sometimes you got to read, sometimes you got to delete, sometimes you got to move, sometimes you got to change the value, like this. So this is called insertion, deletion, modification, accessing, searching, sorting, traveling, etc. and all. We will see these operations in the next video. Thank you.